Hi guys, welcome back. Today we're working on the Honda Accord again, and what we've done is we've taken out the K24 engine. That's over here. It's a 2.4 liter VTEC engine. It's quite heavy, it's quite big, it's supposed to be torquey, and we're going to change this to a rear-wheel drive setup. But for now, we have to figure out how we're going to manage the front suspension of the car. So we're going to trim away this whole section, the front part, the engine bay along with the firewall. We later will separate the firewall from this engine bay area. This is all structural metal. This holds the subframe as well as the shock towers. So we're going to cut away the area of the wheel wells, the shock towers, and whatever holds the subframe together. So we're going to have to keep both sides together and cut it away. And that's the plan for today. We'll cut that off, trim it away. Right now what we were doing is we were clearing up whatever was in the way and would need to go with a part of the car. So right now we had the wiring. The wiring had to be freed up. We also had to clear up any of the brake lines and the fuel lines. That's all out of the way. And now we'll start trimming the car.
Oh, nice. Oh, that's all, folks.
We've now taken apart the car and cut it in two halves. We have the whole area that supports the subframe and the strut towers as one. We later might want to cut away the firewall where the pedal box and everything fits, but this is exactly what we needed. Now what we're going to do is we're going to take this whole section and we're going to place the Cobra body over it to see what more we have to trim and figure out how things should be spaced. So here we're on the chain block. That was a bit of a demonstration of how it works. It's basically a force multiplier. So what happens is we have this thinner chain, and when this moves a certain distance, it creates far less movement in the main chain that's holding the engine up, but far more torque. So that's how it works. So now we moved away the engine. The engine's over there. The engine was in the way of the whole project and we needed to use the chain block to move everything. But now we have the front end of the car. This is where the subframe fits, the strut towers, and everything for the steering rack and related stuff. So what we're going to do is we're going to place this where we want to build the car. We're going to have to cut it down to what we require and trim it down so the body can fit, and then make a chassis around this. That's what we plan to do. We're also going to have to modify the subframe. Possibly that's what it looks like to accept a rear-wheel drive setup. Because the steering rack is in the way currently, we might have to lower it or something like that. That's what I see. But we did have to move a lot of the cars out of the way because a lot of them were parked in here. So that's what a whole day went for. We had to just move everything, and now we have to move this into place. So we're going to push it over here to where we plan to build the car. Basically what we're going to do, the current plan is to take this Honda Accord front end and pair it with the gearbox and the rear suspension of a W124. So that's what we plan to do. Here we go. So we're going to trim away the firewall. We're going to trim away whatever's access over here. So we can basically attach tubed pipes to that, square tube pipe, make a chassis and attach it to this. This here is a 124 rear end. We've got the differential, we've got the suspension. We're just missing the mountings for this. So that's something we're going to have to do now. Attach this and make a chassis. And also somehow pair, obviously we'd want better tires or wheels, but the same PCD. So this runs a separate PCD. This is Mercedes PCD, and this is running Japanese, basically Honda Accord PCD, which is a 5-hole setup, unlike some of the 4-hole setups. So we're going to have to pair that together. So here we have these tools that we use to cut up the cars. We do not use acetylene torches over here because I'm not experienced enough and a little scared about gases. Also, we have plasma cutters, which are easy to cut from what I've seen, but I've not invested in one of those yet. But over here, we have 3 types of tools that we use in our workshop. This here is a pneumatic hammer. It requires a compressor. And what it does is it basically just hammers through. And this is a chisel which cuts the metal. We have this saber saw. This is something Bosch gave us. It's battery powered. It's a reciprocating saw. And basically the saw just moves back and forward and cuts through metal. So they all have their own disadvantages and advantages, but they all serve different purposes. Over here we have the grinder. This can cut through nearly anything, but it does have a lot of dust and sparks and stuff like that. I'll do a little bit of a demonstration on this and tell you guys about all the stuff that they can do and cannot. We'll start off with some safety goggles because everyone likes to troll. Start. So that's what these tools are all about. This one is quite dusty. It's quick. It's not as fast as the saber saw, but these are the most affordable. They're something like this works out to about 4,000 rupees, and it's quite cheap. You just have to change the consumables. It is dusty. It has sparks, so if there are flammable liquids around, it becomes a problem. But they're the most practical for most usages. Also, you can put a flap disc, a sanding flap disc, and a grinding disc on this. You can put a wire brush. You can put a lot of other stuff. So that's why these are the most used around all workshops, the grinders. Second of all, we have this, the pneumatic hammer. I actually purchased this to make a planishing hammer, something you could use to shape metal. But it's not, it requires high pressure, high capacity tank, and a good pressure. Then it works properly. Right now the pressure is low, so it's not working right, but that's a requirement. You need a compressor which can work out to 30,000 minimum. That's what we've spent on ours a few years ago. And this hammer here is about 1,500 bucks. But it would suit for other purposes. Over here it's quite slow. I only use it when I have an access problem. Meanwhile, we have this, the saber saw. It is battery powered. It works the best because it's quite portable. I can use it to cut a car anywhere without having to have power. It also cuts quite fast, especially with a new blade. The limitations are that, let's say you find something which is double walled, like this area. It is a box. What ends up happening is the hammer, the blade ends up hitting the other side and the blades get bent. So that is a problem. We end up having bent blades. So that is the limitation of this machine. Also, it can't cut through the heaviest of materials. Then you'd use the grinder, but it does work quite well for cutting sheet metal. So thanks for watching, guys, and I hope to see you guys in the next video. We'll be using this front end and the back end and trying to pair it slowly. Probably next time we'll be putting everything in place, propping the body and figuring out how to join everything together. And we also have to take this K24 engine and pair it with a Mercedes gearbox. That will take some time, but next time we'll be taking the Mercedes engine and gearbox out of the Lada and trying to figure out how to pair it with this. That is a lot of theory of how to do it. We need to make an adapter plate. We also have to figure out what clutch to use, what starter to use, and all that stuff. So that's what we're going to be figuring out in the next video, talking a bit about one of those topics. And I hope to see you guys next time. Thanks for watching. Bye-bye.